Good afternoon and welcome to Rooted Digging In. This is the first in a series of technical presentations that HydraFiber will be giving over the coming weeks. My name is Daniel Norden. I'm the Senior Technical and R&D Manager for Horticulture at Profile Products. And today I'd like to dive in, since everyone's getting started, to growing chrysanthemums. This year, now is the time when people start sticking cuttings and rooting them. We wanted to go ahead and give a very timely topic on managing chrysanthemum substrate pH. So growers all across the country since 2015, when we first launched HydraFiber to the North American market, have been extremely successful in a wide variety of crops, and chrysanthemums is no exception to that. This is a particular grower that is growing at 40% HydraFiber, and they've had a lot of success. There have been a lot of growers who have done anywhere from 30 to 50% HydraFiber. And just the image that I pulled up here is actually for some trials where we actually grew an 80% HydraFiber. Now, there's some challenges when we go that high with HydraFiber, but I just want to let you know that there's really a lot of growers all over the country that are really pushing the boundaries here. But regardless whether you're growing in 30, 40, 50%, or even higher inclusion rates, success can be had when growing chrysanthemums in HydraFiber. However, there can be some challenges, and with regards to the topic for today's talk, managing substrate pH, this is something that we wanted to bring to everyone's attention as something to avoid. So first, let's talk about some of the signs and symptoms that we're seeing here in these particular chrysanthemums that we're growing. First, we're seeing interveinal chlorosis. So this is basically yellowing in between the veins on the leaves. We're also seeing most of the foliage that's affected is in the upper portion of the plant. When we did a substrate media test for the pH, we found out that the pH was over 7. It was actually at 7.3 at this particular grower. And then when we pulled the roots out and took a look at the rooting of the plants, we found that the rooting was nice, white, healthy roots, so we had no disease present. So from this, we conclude that we have iron deficiency. And what's important to note, and I mentioned under signs and symptoms, that something very important when you see this symptom in the field is always take a look at the roots. Because if you have poor rooting, that can be indicative of either a pathogen, or it could be indicative of water management issues. That can also mask itself as iron deficiency. But regardless, in this particular example, we found that the plants had very healthy roots, and we determined that high pH was the root cause. So there's a couple different scenarios that could find yourself in this particular situation. And we want you to be aware of some of these situations and say, hey, look, if I fall under one of these categories, then I need to take caution and do some testing, make sure that your conditions are correct so you don't run into this issue. First and foremost, if you're using core HydraFiber only blends, we do have some customers that have been growing in peat and core blends, and then they drop peat completely, and they go to a core HydraFiber blend. That's actually the scenario that we have at this particular grower here. When that happens, what happens is we remove the peat, which is highly acidic, and we replace it with HydraFiber, which is acidic, but HydraFiber is poorly buffered against change in pH. So basically that means that the pH can move very freely with regards to HydraFiber. And when we combine that with something like core, which is a high pH, and if we don't make any adjustments to our lime rate, when we remove the peat out of the substrate, then that's when we can find ourselves in a situation like we have in the photo. Other scenarios where we have to take care would be high percent HydraFiber blends. So if you're like 50% or greater, we'll talk about this a little bit more later when we dive into some data here. But basically, as we again continue to remove peat, we remove the buffering capacity of the substrate raw materials. And as I said earlier in the last bullet point, HydraFiber is poorly buffered, and so we need to make lime rate adjustments. Other situations that are non-substrate related would be high alkalinity in your water. So if you have, let's say, 300 plus alkalinity of your water quality, make sure that you're taking the appropriate measures in either your fertility program or your water treatment program to make sure that you're controlling your alkalinity, because that can drive your pH north, even if your lime rate is correct for the substrate that you're using. And then lastly, if you're using heavy-handed watering, as I mentioned on the previous table, that this can lead to similar symptoms of iron deficiency when it's really just due to poor root rooting, which is due to overwatering. So before we dive into corrective actions, let's just talk about like some basic substrate chemistry review. And for proper mum nutrition, we have to keep in mind that the substrate pH greatly influences the availability of most nutrients in the substrate. And so on the right-hand side of the slide, I have a table that comes from, it's actually quite old, from 1982. You can see the citation at the bottom. And basically, it's looking at soil-less substrates, and it's showing nutrient availability as pH changes from 4 to 8. And in the highlighted section from 5.5 to roughly 6.3, this is for most crops the recommended pH range for most plants. And as you can see, different elements, as they fall into that area, their availability to the plant changes. So for example, iron becomes more available the more acidic the substrate is. However, as you approach a pH of 7, iron becomes a much higher limiting factor. So that's important to be aware of. Many plants, as you can imagine, based on this recommended range, prefer a pH between 5.5 and 6.2. However, for mums, fusarium can be a significant pathogen. And because of this, there's been work that's been done in how to mitigate fusarium in chrysanthemums. And what they found is that keeping a pH of the substrate close to 7 helps mitigate fusarium. So in other words, if you keep it above, let's say 6.5, really 6.8 is the target that most growers recommend targeting because it's kind of the nice balance where you have still pretty decent iron availability to the plant. But when you start crossing over 7, that's when you can really start to run into problems if you're not careful. So basically, as you can tell from here, we have to make sure that we manage adequate iron in the mum crop while controlling fusarium, and this can be a challenging task. So what are some corrective actions that we would recommend? Well, immediate corrective actions would be first an iron drench. The first two options, A and B, which would be 2 different chelated iron sources, these would be the 2 that we would recommend, and these are 2 general rates that typically get recommended for iron drenches. Option C can also be used as well, but the problem with iron sulfate is it is acidifying, and so it's going to reduce the pH. So my recommendation is that, iron chelates will not alter the media pH. So if you're targeting a higher pH, iron chelates will certainly help get rid of the iron deficiency without you having to adjust the pH of the growing media. So you can keep the pH elevated to 6.0 to 7 without altering pH. Now, iron sulfate may be beneficial if you find that your pH is, astronomically high, like 7.5 or 8, for example. However, if you do choose to use iron sulfate, do know that you need to mist the foliage after treating it because it can burn the leaves. It can also discolor concrete if you have your plants growing on concrete, so that's something else. The other thing about iron sulfate to keep in mind is that iron from this particular chemical is not readily available at pHs, around 6.5. So even though you add it, you're not going to be getting as much of an effect as if you're using a chelated iron like we have in A and B. So again, in this particular instance, iron sulfate, unless you have a really severe pH issue that you need to correct, it would probably be one that I would avoid. The other option too would be substrate acidification. The first step that I would recommend if you're going to go this route would be to go to an acidic fertilizer. So a lot of these are widely used in the industry. And 20-10-20 is fairly common, and that will work. But I would only use 20-10-20, for example, if you have a mildly high pH, because it's not going to be as acidic as something like a 2177. 2177 is very acidic and is recommended oftentimes to correct high media pH with fertilization. So that would be a scenario where, if you're like 7.5, I would probably recommend using 2177 until you get your pH under control. And then as far as the last recommendation for substrate acidification would be to do a soil acid drench with something like sulfuric acid. Now, this would be, something that I would recommend last, mainly because of safety issues working with acids, but they are highly effective, and they will be much quicker in neutralizing the acid. You just have to be careful, but if you do choose to go this rate, we'd be happy to help. Just reach out to one of your HydraFiber technical reps, and we can make a recommendation on what kind of acid drench to make. Now, we also need to talk about managing into the future. So let's say you get past this issue. Well, what kind of ways should you plan for the future so you don't run into this issue again? Okay, well, first and foremost, proper lime selection. Typically for mums, using something that is like a dolomitic lime is ideal over something like a hydrated lime. The reason being is that hydrated lime can, if you're not careful, you can easily spike your pH because it is much more reactive than dolomite. Also, for long-term crops such as mums and poinsettias, using a coarse lime in conjunction with a pulverized fine lime is a good management strategy because you can balance, a quick release or neutralizing the acid quickly with the fine lime, with a long-term strategy with the coarse lime, which is going to give you good lime residual over the 3 to 4 months that you're growing the mum crop. We highly recommend routine calibration of mixing equipment. So if you are making your own blends, if you're running into pH issues, it's extremely important to go back and check your hopper calibrations as well as your peat and HydraFiber machine calibrations, because these things can all greatly influence your substrate pH. And we recommend doing this at least 1 time per year, ideally twice per year. Reducing lime rate. Well, if you go in and you check that your equipment is functioning properly, the next step would be, and you're using the correct lime source, then the next step would be to look at doing lime rate reductions. We always recommend ruling out the first 2 things first, because when you reduce your lime rate, if you assuming you have the right lime and your equipment is not malfunctioning, then you have to be careful that you do not reduce your lime rate too far, because essentially most instances it is much more difficult to increase your pH of the substrate as opposed to reducing the pH of the substrate. And that tends to be true for most growers. So it's always better to be high than it is to be too low. So take care when you start looking at evaluating your lime rate in your growing media, and make sure you do adequate testing and trialing before you settle on the right lime rate. Routine water quality checks. As I mentioned on a previous slide, be familiar with your water alkalinity and water quality overall. A lot of times, many growers get confused between water pH and alkalinity. These are 2 very different parameters that are measured in water tests. They are related. However, water alkalinity refers to essentially the buffering capacity, or the carbonates and bicarbonates in your water that essentially buffers the pH. And if you have very high pH, that may not matter. Whereas if you have very high alkalinity and you could have completely normal pH, then that can still drive your pH up and then result in iron deficiency. We recommend testing your water at least once per year. But if you have a water source like from a stream or river where it can be highly variable, then you probably should check your water much more frequently than that. For mums, because the situation is maintaining a high pH, you may want to look into routinely adding chelated iron into your fertigation program. This is probably something, if you find out that your pH is around 7 and you're still struggling with iron deficiency, then this may be the solution that you ultimately need to go to. So you could talk to your fertilizer supplier to make a recommendation for this, so you can either supplement your current fertilizer or come up with a custom blend that has higher chelated iron in there. And then lastly, always test, because having the right data before you encounter a problem is always going to help you take corrective actions much sooner than when the plants get extremely chlorotic and avoid plant losses. So the good news is that these are the plants right before they shipped, and this was from a grower trial from 2016, and the plants on the left are the control, the mix without HydraFiber, and then the plants on the right were the plants with just core and HydraFiber that had the chlorosis. And based on the situation, we were able to take corrective action through a combination of using 2177 acid fertilizer with a chelated iron drench, and we were able to correct the pH, and the crop turned out just fine. So if you identify these signs and symptoms early enough and you take corrective action, then typically this is not a problem. So I just want to cover a couple other things. When you're making the transition to HydraFiber mixes, we can help you more effectively manage your pH. And I mentioned earlier that when growers start reducing their peat moss in their substrate, they're reducing their buffering ability in the substrate because of the acidity and buffering of peat moss itself. And so from university testing with Dr. Ryan Dixon at University of New Hampshire, we came up with this rule that basically for every 10% of peat that you remove from the substrate and replace with HydraFiber, you should look to reduce your lime rate by roughly 10%. So this is a pretty easy rule of thumb. And a lot of our grower customers that when they, let's say they were growing in an 80 peat, 20 perlite, most growers start with 70, 30 peat HydraFiber. Typically a 10% reduction in your lime rate is all the change that you need to make. But if you need help with this and making a recommendation, we're always here to help, and certainly reach out to your HydraFiber technical rep. So let's just touch on a couple things as it relates to HydraFiber managing pH. So what we found in the university trials is that HydraFiber is less buffered compared to other raw materials, but it's also important to understand that the amount of lime that's incorporated into the substrate plays a much larger role in pH buffering than the raw materials themselves. As you increase HydraFiber, this will reduce the amount of lime needed. And this goes back into a point I made earlier that, if you're growing in high percentages of HydraFiber, let's say 50%, you're going to have more risk of running into high pH related issues if you're not making sure that you do the proper testing up front to make adjustments to your lime rate. And again, we can help make recommendations for your specific situation. So even though HydraFiber will reduce the amount of lime needed, we also looked at different fertilizer sources to see what the impact would be as we increase HydraFiber. And what we found is that with acidic-based fertilizers like 20-10-20, there's a much higher risk of pH drop as you go up in HydraFiber inclusion rates. And this is because you have less buffering because there's less lime in the substrate. There's very little risk when you're using a basic or alkaline fertilizer of pH going too high. So really the risk is if you're a grower that relies heavily on like a 20-10-20 for mum production, and you go to a 50-50 blend and you reduce your lime too much, you could run the risk of tanking your pH. So again, this is where we can help. We can provide recommendations so you don't run into the situation. And again, like I discussed on the previous slide, the rule of thumb to keep in your mind is that for every 10% peat that you remove and replace with HydraFiber means that you should look to reduce your lime by about 10%. And always, anytime you change your lime rate, it's always important to test the new lime rate on a small scale before rolling it out to your to all of your production. So let's review what we learned today and some things that we want to keep in mind. First, always, it's important to diagnose correctly. Make sure you're collecting the right kind of data. Make sure that you're frequently collecting data so that you can diagnose correctly. In this particular situation, we had good root development with the grower in question, but we had high pH. And so based on the visual symptoms, we were able to conclude accurately that we needed to treat with chelated iron, as well as work on lowering the pH. To help manage fusarium, it's important to keep your pH around 6.8, anywhere close to 7. When you start going above 7, this is when you can run into iron issues. And again, we highly recommend using a chelated iron for this particular situation. It's always important to routinely calibrate your equipment to make sure that your peat, your HydraFiber, your lime, your fertilizers are dosing correctly, and this will help mitigate any of these pH-related issues. Use the right lime. So if you're relying too much on hydrated lime, for example, and you're, you may have some dolomitic lime that's available or a coarse lime that's available from your vendor, then make sure that you're using the right lime for the right crop. And as always, test, because this is going to give you the best information to help make the best treatments. Again, for every 10% of peat that you remove and replace with HydraFiber, you should reduce your lime by 10%. And lastly, don't be afraid to go high. As we saw very early on, in the first slide or second slide, we saw that a grower with growing in 40% HydraFiber had no issues. And we've had growers who have gone even higher. And mums love well-oxygenated root zones. It's going to help them root better. And so, again, don't be afraid just because you can run a little bit more risk of running into high pH issues as you go up into HydraFiber. We're here to help, and we can make recommendations so you don't run into this problem. And for that, I thank you for your time, and hope everyone has a good day.